Why did I title this video Geometry and Me, Enemies to Lovers? If you're not interested in the lore, I've put the timestamp down below so you can skip ahead. But the reason I titled this video Geometry and Me, Enemies to Lovers is pretty straightforward. Frankly, I did not like geometry. When I was considering my favorites among the 4 subjects, I liked algebra, combinatorics, and number theories all equally. They were all my favorite. The only thing was that I hated geometry. And recently I went on a 2-week trip to the UK for winter break, and that's actually also the reason I haven't been uploading for the past 2 weeks, but now I'm back. As a surprising side effect from the trip, I actually somehow have fallen in love with geometry. Well, the story goes like this. I was bored on the bus, I would say, and so I decided to try a G1, a shortlist G1 problem, and somehow I found it quite easy actually in the way I solved it. And so throughout the next few days, I kept attempting new geometry problems. Like I went from G1 to G2 to G3, and just this morning actually, I solved a G4, which I'm really proud of. But I guess it's just that I've somehow found like my geometry style. I found the beauty in geometry, how elegant everything can be when you simplify it all down. And it's quite difficult for me to explain. So I think the best way for you to actually experience that feeling for yourself is for us to tackle this problem today that I have chosen. And this problem is IMO 2024 problem 4. It's also a G2 on the 2024 shortlist, and this is one of the first problems I have tackled on my geometry revolution, I will say, on my enemies to lovers journey with geometry. And luckily I successfully solved this, so I hope you enjoy this problem as much as I did. Alright, so the problem goes like this. We have a triangle ABC. We define its incenter I and its incircle. Then we construct a line parallel to AC that is tangent to the incircle. We let this tangent line intersect line BC at X. Similarly, we construct a line tangent to the incircle that is parallel to the line AB, and we let this line intersect line BC at Y. So now we have defined X and Y. So we go on to define 3 more points. P is the intersection between line AI and the circumcircle of triangle ABC, which, if we are familiar, is actually just the midpoint of arc BC. And then we define K and L as the midpoint of AB and AC. So now that the problem setup is done, we want to prove that angle KIL plus angle YPX is equal to 180 degrees. Again, I encourage you to pause this video and try to find something out about this figure by yourself first. Now, let's jump straight into the problem. Before we try to find anything else out about the angle KIL, there's one thing that catches my eye first. So let's define the intersection point between this line and this line as A prime. And the problem tells us that A prime X is parallel to AC and A prime Y is parallel to AB. Well, that's interesting because the line XY is just the line BC, so they're obviously parallel to each other. So we have that the triangle ABC and the triangle A prime YX, these 2 triangles, their sides are pairwise parallel. That means that these 2 triangles are similar, which is pretty nice. Okay, so now let's take a look at this angle KIL and try to see if we can represent it as something else, because K and L are so haphazardly defined, they're just the midpoints. And well, since they're midpoints, we might notice that something's interesting with triangle AKL and triangle ABC, which is that they're similar. And that's pretty cool, but we should be a bit more specific here. We know that they're similar with a scale factor of 2, and they're being scaled up by A. So we can actually use a bit more professional terminology here, which will, as you'll see, give us some actually quite useful information for later. So AKL goes to ABC with a homothety at A, so a homothety centered at A with a scale factor of 2. So let's just put this here. And it's quite natural to think about where this line or this point I would go under the same homothety. If we know that this I goes to somewhere, then we know that angle KIL will be equal to angle B somewhere in C. And you might guess that I would go to A prime since that looks like it, and you would be right, but we have to prove it. So there are two parts in proving this, which is first that A prime are collinear, and then we have to prove that AI to AA prime is 1 to 2. That way it would actually go there under the homothety. So let's first work on the first step, which is proving that AI and AA prime are collinear. Well, we know that AI is the angle bisector of angle BAC, and we also know that A prime I is the angle bisector of angle YA prime X, because this circle is actually just the A prime X center of the triangle A prime YX. So there's multiple ways you can go about doing this, but for example, I'll just show one way, which is that A prime, this line, is A over 2 since this bisects this, and B and A prime, this is also A over 2 since this bisects it. And since these two things are parallel, we must have that AI and A prime I are the same line, so A prime are collinear. Okay, so we have gotten that first step. Let's write that down because it might be easier for us to see later. Collinear. Okay, now the second part is to prove that AI to AA prime is 1 to 2. And this is equivalent to proving that AI to IA prime, or AI is equal to IA prime. And again, there should be many ways to do this, but my favorite way of visualizing this is to, let's say, just draw a line over here. It's a very ugly line, but it works. So, by the way, this line should be parallel to BC. So what's the significance of this? Well, if we look at this triangle that's formed by this point, and A prime, then we know that this angle right here, this angle, is equal to this since they're parallel. And this is equal to this, so this is angle B. And similarly, this is angle C. And we already know this is angle A, so this triangle is actually similar to triangle ABC. But what's even better is that it's not only similar, it's also congruent, because this circle is the incircle of our new triangle, but it's also the incircle of our old triangle ABC. So their sizes are the exact same. And since these two things are similar, any component in them will also be similar. In particular, AI in our ABC triangle corresponds to A prime I in this triangle. So AI is equal to A prime I. And that is exactly what we wanted to show. So let me undo all this and write down our final conclusion here, which we've proved that A prime are collinear, and we've also proved that this ratio is indeed 1 to 2. So we know that I will go to A prime under this homothety at A. And so we don't need this collinear part anymore because since it's the homothency that already implies it. Okay. And so as we've mentioned, since this homothency maps K to B, it maps I to A prime and maps L to C, we have that the angle KIL is equal to the angle BA prime C. Okay, so what's neat about that is now we don't have to do anything with K and L anymore. We can just throw them all away. And what we are left with is to prove that angle BA prime C plus angle YPX is equal to 180 degrees. Well, that still seems a bit difficult to prove because BA prime C looks really irrelevant, and so does XPY. So how can we prove this? Well, when I was doing this problem, the thing I thought about was that let's swap these A prime and P for a bit. So instead, let's take a look at angle BPC plus angle XA prime Y. Well, we know that angle BPC is the minor arc PC, which is equal to 180 degrees minus angle A, and XA prime Y, since it's similar to ABC, this is angle A. So this is actually equal to 180 degrees. And well, that's pretty cool. If we swap these around, then it's equal to the sum that we want. So maybe we can show that the increase in angle, or rather the decrease in angle here, is equal to the increase in angle here. Okay, so what do I mean by that? Well, let's take a look. So let's look at our BA prime C, and let's compare it to XA prime Y. So BA prime C, let me write that down. BA prime C is equal to angle XA prime Y plus angle XA prime B plus angle CA prime Y. And then on the other hand, we have angle XPY and angle XBPC. So angle BPC is equal to angle XPY plus angle BPX plus angle CPY. Alright. So what's neat about this is that we already know that angle BPC plus angle XA prime Y, which let me highlight here, BPC and XA prime Y, these two angles add up to 180 degrees. And now we want to show that these two angles add up to 180 degrees as well, which just means we'll have to show that the offset here is equal to the offset here. Since this is quite symmetric, it is natural to assume that XA prime B is equal to angle BPX. And similarly, we would also have that angle CA prime Y is equal to angle CPY. Then these two sums will be the same. And we will be able to show that what we want to prove is true. So it remains to show these two, which since they're symmetric, we can just prove one of them. So XA prime B, which is this angle, is equal to XPB, which just means to prove that that the 4 points B, X, A prime, and P are concyclic. Okay, so we've simplified our entire problem, which is consisting of proving that KIL plus XPY is equal to 180 degrees. We have this complicated expression, and we've simplified it down to the simple step of proving that B, X, A prime, P are concyclic. So this is what we want to show. Okay, so how do we do that? And well, this is actually already our last step here, and it shouldn't be that difficult. So for example, we can consider, well, these 4 points are concyclic if and only if, it's actually a direct, necessary and sufficient condition, that this angle is equal to angle A prime PB. If you're not familiar with this, you'd have to take a look at your formulas again. But first of all, A prime PB, we know that A prime I and A are collinear, and P also lies on this line because AIP are collinear. Well, it's defined there. So this is actually just equal to angle APB, which is equal to angle ACB, which is what we call angle C. And angle YXA prime. Recall that we have this, I erased it, but we have that this triangle is similar to this triangle. So this angle will correspond to this angle, which is equal to angle C. Okay, so we have that this angle is equal to this angle. And that is exactly what we wanted to prove. So we get that this is concyclic, which, as we have already proved before, this implies what we want to show, which is that KIL plus YPX is 180 degrees. Okay, so that is it for this problem. Well, what is the takeaway here? Well, I guess the key part here was noticing the point A prime and how it relates with the rest of the figure. So for example, being able to transfer this angle KIL down to BA prime C, that was definitely a very helpful part. And just even in the beginning, spotting that these two triangles are similar, you couldn't really go anywhere without that. So similar triangles is definitely one thing. It's like the most important part of all plane geometry, all Math Olympiad geometry, so we definitely have to pay attention to that. And then a little extra special is, I guess, transformations. It was highlighted in this problem, which is a transformation, is a homothety from A with a scale factor of 2 that transformed this figure down to this figure here, and that helped us prove the relation we wanted to prove. So we can use transformations to transform our desired values into another value that's hopefully easier to compute. So that's it for this problem. I hope you enjoyed this nice geometry problem as much as I did, and I'll see you next time.